Welcome to your next lesson from Beaver on the Go. Today we are going to talk about mixed numbers. And you're probably like, Miss McDormand, what the heck is a mixed number? I promise you, I've heard you use them all the time. It's something super simple. A mixed number is the combination of two things. Let me move this real quick. I can't reach it. So, a mixed number is a whole number so 1, 2, 3, 4, 5, 6 to infinity. Those are your whole numbers. It's a whole number and a fraction. I've heard you guys say it when you're talking about food. Oh, there's only 1.5 pieces of candy left. There's 2.5 pieces of candy left. You guys use them, you just didn't know what their math name was. And you know, I love when we use the correct words and terms. So, a mixed number is a whole number. Let's pick any whole number. Today's the first, so we use the whole number 1. And any fraction, let's say 5/12. You have a whole number and a fraction. It could be 327 1/2. A whole number and a fraction. Any whole number. It could be 1,000,000,000. No, probably not, but it could be. It's any whole number that's combined with a fraction. Yeah, a whole number and a fraction. That's it. So, let's talk about some examples. You guys were doing them. You guys were starting mixed numbers with your fraction work you did yesterday. Some of you used an apple, some of you used paper. So, I'm going to do something different than an apple because you worked with those eighths. So I'm going to do cake because I'd like some cake. Let's say we have 3. I'm going to do one more. Let's do 4 cakes. 4 cakes. And these cakes are cut into thirds. So they're cut into 3 equal pieces each. So these guys are cut into thirds. So this is the activity you guys did yesterday when you were adding your number of thirds. So you start with this guy, 1/3, 2/3, 3/3. Remember, we talked about this before we left for our break, and that anytime your numerator, your top number, and your denominator are the same, that means you have the whole object. So if you have 3/3, you have this whole cake. Now we're continuing on. Remember, your denominator doesn't change because that tells you how many pieces these guys are cut into. We can add these because they're all cut into thirds. So here's 3/3. So this guy would be 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, and then we have 10/3, 11/3, and 12/3. Now, why do we use mixed numbers? Because they make more sense than saying, well, I have 12/3 of something. We don't use that. It's kind of like when we talked about money. When you go to Target, it's done in dollars and cents, not all cents. So if I want to buy something that's $5.75, we don't say, well, that's 575 cents. No, we make it easier. mixed numbers make, when you have a larger numerator than a denominator, easier to understand. So if you get something like 12 thirds, you're like, oh, I have more than 3, so I have a lot of wholes. So let's see how many whole cakes we have. So this guy's a, hold on, I said that wrong. So if you have all 12 thirds, you have 1, 2, 3, 4 whole cakes. So 12 thirds equals 4 whole cakes. All right. Well, people like cake. They're going to eat it. So let's say some of these cakes get eaten. So my dark blue marker will show what gets eaten of these cakes. So let's say out of this one, this piece gets eaten, and this piece gets eaten. And out of this one, this piece gets eaten. And let's say this one gets eaten. And let's say this one gets eaten. So our lines mean that these pieces of cakes are eaten. So you're looking at this and you're like, goodness, I wonder how much cake I have left. So let's count up the pieces that we have left. I'm going to do it in the same dark blue color. So now we have 1/3 here, 2/3, 3/3, 4/3, 5/3, 6/3. I'm going to write it right on it. 6/3, 7/3. 7/3. I'm not going to go to someone and say, I have 7/3 of this cake left over, because people are going to be like, what are you talking about? That's too hard to understand. So we're going to change it into a mixed number. So let's figure out how many whole cakes we still have left. We know our denominator is 3. So 3 pieces is a whole. So this guy, 1/3, 2/3, and 3/3. This one, and this one. That's 3 pieces left over. They make up 1 whole cake on their own. So I'm going to circle them and say that's 1. If I have 3/3, that's a whole. All right, so now I'm looking for another 3/3. Here's 1/3, 2/3, and 3/3. So we counted these guys already. So 4/3 makes another 1/3, 5/3 makes another 2/3, and 6/3 makes another 3/3. So these guys here make up another whole cake. So we have 1 whole cake here. 4/3, 5/3, and the 6/3 make up a second whole cake. And look, we have this 7/3 piece left over. So we have 1/3 of those original pieces left over. So we have 1 whole cake, 2 whole cakes, and 1/3 left over. So 7/3 equals 2 wholes and 1/3 left over. So when you ask at the end of the party, well, how much cake do you have left? I have 2 1/3 piece of cake left. That tells somebody you have 2 whole cakes, and then 1 piece out of 3 pieces of the last cake. So when we counted them, we had 7/3 left over. 1/3, 2/3, and 3/3 made up 1 whole cake. Those 3 pieces made up the 3/3 for the 1 whole. 4/3, 5/3, and 6/3 were 3 pieces, so they made up another whole cake for 2 whole cakes, and then 7/3 was our 1/3 that was left over, and he made up the last 1/3. So 7/3 equals 2 wholes with 1/3 left over. So what does it look like in a story problem? We get a marker to make my, so that's down here. So bear with me. I know my pizzas are not totally equal. I didn't want to work in eighths. You've had a lot of practice with eighths, so I changed it up a little bit. So just pretend and go with that my pieces are all equal size. So our problem, Ms. Newdorman ordered 3 pizzas with 10 slices each. The first pizza had 6 pieces left. The second had 8 pieces and the third had 2 pieces left. How much pizza does she have left? So let's start with, we know first that our denominator is going to be over tenths because each pizza is cut into 10 equal pieces. So our denominator tells us 10 equal pieces in each pizza. If we were going to add up the total number of pieces of pizza, 10 pieces here, 10 pieces here for 20 pieces, 30 pieces here for the 3 holes. So altogether we have 30 tenths. Again, this is why we changed it into mixed numbers. Nobody wants to say 30 tenths. 30 tenths means 3 whole pieces, 3 whole pizzas. It's much easier to say 3 whole than 30 tenths. So let's look at what of our pizza we have left. So the first pizza had 6 pieces left. 1, 2, 3, 4, 5, 6. Okay? This guy has 6 tenths left. This pizza had 8 pieces left. Nobody liked this pizza. 1, 2, 3, 4, 5, 6, 7, 8. This pizza had 8 tenths left. And this pizza had 2 pieces left. 1, 2. So 2 tenths. We could add these guys up. So 6 tenths plus 8 tenths plus 2 tenths. Remember, denominator does not change. You can't change, you can't add fractions that don't have the same number of equal pieces. Remember, you'll learn about that starting in 3rd and 4th grade. But for now, we're only doing same denominators. So 6, so we're only adding our numerators. 6 pieces of pizza plus 8 pieces of pizza is 14 pieces of pizza, plus 2 more gives us 16 pieces of pizza. So we have 16 tenths of pizza left. Nobody says you have 16 tenths of pizza left. So we have to figure out how many whole pizzas do we have left and how much do we have left over in fractions. So to make a whole, we know we need 10 pieces. So I'm going to go in purple and we're going to get 10 pieces. So we have this 6. I'm going to put a line through them. 1, 2, 3, 4, 5, 6. We haven't made a whole yet. 7, 8, 9, 10. Oh, now we have 10 whole pieces. So our purple gives us 1 whole. Let's see how many we have left over. Let's see if we have enough to make another whole. 1, 2, 3, 4, 5, 6. Oh, we only have 6 pieces left over. We don't have enough to make another whole. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We only have 1 whole we can make out of that. So there's our 1 whole. 10 pieces put together makes a whole pizza with 1, 2, 3. Am I counting right? Oh, I missed one. 1, 2, 3, 4, 5, 6 pieces left over. But it's not 6. Remember, it's 6 tenths because it's 6 out of the 10 pieces. So we have 6 out of 10 pieces left over. So our 16 tenths gives us one whole. We can get 10 pieces to make one whole. There's our whole number. We made it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When we combined the 6 pieces from the first pizza and 4 pieces from the second pizza, we put back together one whole piece of pizza. After we put that together, we have 1, 2, 3, 4, 5, 6 pieces of pizza left. We don't have enough to make another whole because it takes 10 to make a whole. So we have 6/10 remaining. So we have one whole pizza, which is 10 pieces, and we have 6 out of 10 pieces left over. So instead of saying we have 16/10 of pizza, we have one whole pizza and 6/10 left over. So there you go. That's how mixed numbers work. You will be watching, I don't remember if you've watched the Brain Pop yet or not. I know tomorrow's activity is a quick exit ticket. It's about taking a fraction with a larger numerator than denominator and turning it into its mixed number. So you get a number like 16/10 and you're like, oh, if I have a bigger numerator, I have at least one whole, maybe if not more. So it's about turning a fraction with a larger numerator than a denominator into a mixed number, a whole number, and the fraction. So there you go. There is your second lesson today from Beaver on the Go.